Hello everyone, my name is Alan. I'm going to be a first-year master's student at the University of Chicago with the Activated Experience Lab. And I'm giving the talk on Buoyancé, reeling helium-inflated balloons with mobile robots on the ground for mid-air tangible display, interaction, and assembly. And I'm giving this talk on behalf of my co-authors, Yu Xiaobi, Miyu Fukuoka, and my advisor, Ken Nakagaki. So balloons are everyday objects that are commonly rolled into our everyday lives and cultures. As seemingly magical floating entities, they bring energy to social occasions to lift up the spirit of people celebrating important life milestones and family occasions. They have the unique material quality of being soft, comforting, and safe to touch, squeeze, or hold, taking diverse forms or sizes that fit the user's needs or desires. And I'm sure many of you have had the experience with balloons before, having wanted to just have a magical floating entity connected to us, making us happy, simply connected to us by a simple string. And these helium-inflated balloons have gradually made their way into prior research as well. In some cases as theory or their own, and even as recently as yesterday, if you attended yesterday's Interaction in the Real World session. But they have also made their way into robotics as a way to obtain more robust upright positions, and even just improving general maneuverability in 3D space. But the general goal our goal with Buoyancé was to create a mid-air tangible actuated user interface, which we define as multiple mid-air objects that can be controlled and interacted with people. This has been a well-researched topic in the past, which has been implemented with various methods such as ceiling rigs, drones, as you can see here, and also ultrasonic phase arrays, as one of the many other implementations, including levitation, acoustic levitation, or magnetic levitation. But what we propose through Buoyancé is using HIVs, helium-inflated balloons, and real bots. And so we propose Buoyancé, a novel mid-air actuated tangible user interface using helium-inflated balloons with real bots. Our approach is safe and our approach has a unique implementation of being safe and approachable for users to interact with, posing little to no risk and also having minimal noise. It is also scalable and deployable, making it easy for room-scale actuation with efficient energy levitation. And lastly, since we're using a common everyday item that brings itself to many people's lives, it also has unique, enriched, and embodied interactions for people to understand. Here we have our comparison table, which relates it to passwords. For the sake of time, this is the detail in the paper. That moves us into our design space. And at a high level, Buoyancé is just a helium-inflated balloon that can take any shape or size, headed to a real ball on the ground. And with this, we're able to have 3D motion along the ground, being able to control where the balloon is along the 3D space. And if we want to expand it a little bit more, we can also connect 2 robots to 1 balloon to increase the level of control to pitch and yaw. But furthermore, our system also allows for constructive mid-air assembly. And in doing so, we are able to connect multiple robots to essentially what is one levitating object. And in doing so, we are able to expand our level of control to all 6 degrees of freedom, controlling pitch, roll, and yaw, as well as the 3-dimensional movements along 3D space. This allows for unique interactions and affordances with the constructive assembly. We are also able to self-disassemble as well when the constructive assembly is no longer desired. This enables for unique interactions and affordances, some of which are built on the affordances of how balloons show themselves in everyday life, including our via string tangible control, our direct tangible control, as well as nearby gesture control. So that forms the main component of our design space. Moving into our implementation, our system consists of a software architecture and hardware design. Our software is based on the OptiTrack motion capture system, along with our custom-built GUI, which you have seen throughout the past slides. And our hardware, which is built on which is built on commercially available off-the-shelf rovers, as well as a reeling mechanism that allows us to have three-dimensional maneuverability. And if you'd like to take a closer look at this, feel free to come after the session. And as I mentioned, we are also able to move the balloons up to 150 meters in the air, enabling for rich applications as well. The users are able to control these through various control methods, such as our OptiTrack hand-based tracking, media pipe-based body and hand tracking, or normal everyday custom keyboard and mouse GUI. You can also hardcode animations to pre-scripted animations, and also use a modern game controller to have a little bit more fun with it. We conducted a technical evaluation, but for the sake of time, we'll just flash on the screen here. You can discuss the detail in the paper, so feel free to go take a look at the paper as well. That moves us into our applications, and because we are able to move it into 150 meters in the air, we're able to represent real scale displays. Things that are typically hard to display because of their height, such as the previous giraffe or this now elephant. We can also have it more performative applications, as a real-time mirror posing. You can also use it as educational purposes, enlarging mathematical functions for more in-person, tangible understanding of these items, such as a wave, and then now a circle. We are also able to help users assist users with configuring their rooms around, lighting up certain areas while keeping their hands free so that they are free to read a book, or if they want to have a little bit more stability while climbing up a ladder so that they can also use their hands to fix objects higher up. And if users no longer desire the need for the robots are able to neatly store away in the air so that users no longer have to worry about stepping on them or able to go about their lives without sight, out of mind. With our constructive assembly, we are also able to create dynamic shape formation so that we are able to create long all day advertisements such as HCI that is able to dynamically change their orientation to fit the user. We are also able to create dynamic shape formation, which not only able to move themselves, but also able to essentially change their emotion. We conducted a user study to better understand how users experience our system, along with comparing our 3 hand-based tracking systems. This study was with 12 participants, and we asked each of them to have a targeting task to move it to one 3D location defined by one location along the ground, as long as the height. We had 5 tiles per target point, with 6 targets, leading to a total of 30 tiles for each user. Here are some of our results, which I'll briefly glance over. But one thing that we learned from our user study was that the real bots, our system allows for rich affordances and interactions. While we intended the real bots themselves to act as more of a stagehand, many of them found themselves as a common companion, which we have also found with previous papers. Height change has also affected the preferences, whether or not someone likes a control method going from a high location to a low location, or vice versa. And it's also often related back to childhood memories. We're also fortunate enough to exhibit Buoyancé in 2 separate occasions outside of the paper. And one thing that we found on both occasions is that people, especially children, are attracted by the balloons and robots, which allow for a rich spatial and body tangible interaction. For our future work, we would like to scale, since we are using a Wi-Fi connection, we would like to scale up the robot numbers to create more diverse displays, as well as improve the hardware improvements. As we are using a Mylar helium inflated balloon, which has been shown to conduct electricity, we'd like to use it to enrich our sensing, as well as just generally improve our applications utilizing the full capability and potential of helium inflated balloons. And so, in conclusion, we propose Buoyancé, which is a novel interface for mid-air tangible actuated user interfaces. We view this Buoyancé as merely a beginning, as a way to create interfaces that not only create interactive embodied experiences, but also actuate its users to seek these embodied interactions, as well as build upon everyday items to create tangible interactions. Thank you, and we would also like to thank the rest of the, we also like to thank those who have helped along the way, and I'm open to questions. Thank you.